In lecture, we have learned about how to make epoxides using MCPBA. They can also be made using dimethyl dioxirane, or DMDO. We will be using this method in lab, in which DMDO is made in the reaction from acetone and oxone in solution. The DMDO can then be used to form the epoxide from cyclohexene. In this experiment, we will also be using the rotary evaporator. The rotovap is used to remove solvent from a mixture, leaving behind an oil or solid. The rotovap has a boiling flask containing your mixture. There is a water bath warming the flask to help the solvent to move into the vapor phase. A water-cooled condenser coil will cool the vapors and condense into a liquid to be collected into the receiving flask. A bump trap is also present in case solvent bubbles up too quickly before it vaporizes into the condenser. There are also keck clips needed to hold the flask in place, or it will fall into the water bath. A vacuum is applied to the system, reducing the pressure, which will lower the boiling point of your solvent. This will further aid in evaporation of the solvent. As the water bath warms the solvent in the boiling flask, the volatile solvent will be pulled into the condenser, and the cool coil will allow the solvent to turn to liquid and drip into the flask, leaving behind your non-volatile solid or oil. Make an ice bath in a beaker that is large enough to contain a 50 ml Erlenmeyer flask. Add to the flask cyclohexene, acetone, and a stir bar. In a different beaker, make a solution of oxone and water. Add the oxone solution slowly into your flask. If the reaction looks too vigorous, slow the addition down. When all oxone has been added, remove the ice bath and stir the reaction at room temperature for 30 minutes. Transfer the reaction mixture to a separatory funnel and add 5 ml of dichloromethane and 5 ml of water. Put the stopcock in the funnel and invert several times. Release built-up gas as needed. Drain the organic layer into a clean beaker. And then add 5 more ml of dichloromethane to the remaining aqueous layer and extract again. Remove the aqueous layer from the funnel. Pour the organic extracts into the funnel and wash with 10 ml of water. Drain the organic layer into a clean beaker and dry with sodium sulfate. The sodium sulfate will clump up any water that was left. You are looking for clumps and sodium sulfate that can still move when you swirl the flask. If there are only clumps and there is no free-moving sodium sulfate, you will need to add more. Decant the liquid of the organic layer into a clean round-bottom flask. Remove the solvent with the rotovap. Clip your flask onto the bump trap. Turn on the water bath. This should not be set any more than 40 degrees. Turn on the rotation at a moderate speed. Turn on the cold water. Open the vacuum. You should hear hissing. Close the vacuum to the system by turning the knob. Watch for bubbling in your boiling flask. If you notice your sample bubbling up too much and going into the bump trap, release the vacuum slowly to the system and then close it again. When it looks like all of your solvent is gone, release the vacuum, turn off the vacuum using the knob. Unclip your flask. Obtain an IR and an NMR.